Want to turn your organization's data into a strategic asset? Pragmatic Institute offers training to data and business teams with a practical, hands-on approach. Discover how Pragmatic can help you build a culture of data-driven decision-making at pragmaticinstitute.com/data. Welcome to Data Chats, a podcast by Pragmatic Institute and the Data Incubator, where we tackle data topics and trends with experts, industry leaders, instructors, and alumni. I'm your host, Chris Richardson, and today I am sitting down with Favio Vazquez, data scientist and solutions engineer at H2O.ai, an end-to-end platform for machine learning that enables the usage of AutoML, deep learning, and generative AI to solve business problems. Favio leverages his knowledge in mathematics, data science, and machine learning to help different customers in Latin America. And I am thrilled to have you on today. Thanks for joining, Favio.
Thank you, Chris, and thank you for the invitation. I'm excited to be here.
Well, lots of timely and sort of futuristic things to talk about today, I'm sure. But maybe before we start with all of that stuff that you're into now, maybe you could say a little bit for our audience about where you're coming from. So what kind of experience you have that brought you to where you are?
Of course. So I'm from Venezuela, living in Mexico at the moment. My career started in science. So I'm a physicist. That's what I started. I also did an engineer in computer science. And I came to Mexico to do my master's degree in physics as well. All my academic career was around black holes, cosmology, and extragalactical science. But in that process, I realized that something that is crucial for everything, and that's data. So I started understanding lots of different methods and techniques to deal with large amounts of data. First, to do my thesis and to do my day-to-day life as a student, but also as an interest of mine. So I discovered that I was very interested in data. Of course, I'm also interested in physics and the world, but I saw an opportunity to work in that space. That was around 2013. So the words data science, machine learning were not that famous. And the beginning was kind of weird because what I said I did was data mining. But now thinking back, I was doing data science without even calling data science. I think a lot of people have that experience. And after graduating from my master's degree in Mexico, I started working in several companies, banks and retail companies, and I did my own company for helping people to get started in data science. And right now I'm working in H2O. It's an amazing company doing great stuff for Latin America around machine learning, AI, and stuff like that. So yeah, that's my background in general. One thing I would like to mention is that I think that a lot of people are coming from science to data science. And one of the trickiest part for me was the business part because I really didn't know anything about that. So I had to start from scratch. Maybe later I can dig into that.
Yeah, absolutely. And I think that you hit it right away, is that one of the challenges is that people are coming maybe from math and science, hard sciences. My background was more humanities, and I'm not a data scientist per se, but definitely involved in the general area. And so I'm seeing a lot of different groups who have different kinds of training, a lot of them gravitating to this because, as you said, a lot of people are doing data science without necessarily knowing it or calling it that. So yeah, maybe we can dig into that to start with. What were some of the things that you learned as you got into a more professional organization, like business-driven organization, that were either new to you or that you just hadn't thought of in the same way coming from a more academic background?
Yeah, I think so. Several things. First of all, the urgency. So when you are in an academic scenario, so of course you need time because you want to graduate and you want to publish papers and so on. But in my experience, it was not that like a hard deadline. So you have to finish this by this day because this is the budget. So now it's kind of tricky because science is becoming more bureaucratic as well. So we do have deadlines and you do have to do a lot of stuff and you have budget and so on. But as a student, you don't feel that. You feel like you're working and you can work for this project for a year or two and you will be happy. Your supervisor will be happy and so on. So the urgency was something that I have to learn very fast, that there is a time frame to build projects. and you have to stick to that time frame and budget. If not, you will lose, the company will lose. It's not going to get into production, and it's not going to get value for anyone. So that's the first thing, urgency. I think the second one was structure. So of course, in the academia, we have structure and so on. But in businesses, we have a lot more of a structure, meaning you have a boss, that boss has a boss, you have sometimes people underneath you, you have coworkers. There's a lot of things going on that you have to understand. And the requirements for you, I mean, it's not up to you anymore. So you are in a group team. Science kind of works like that, but you feel more liberated sometimes. In here, you really can't do things by your own. So that was the second thing. I mean, I kind of learned to work as a group while studying and other work I did before entering into data science. But when I was into data science for real, that's what I felt like, how to work as a team. And finally, I think one of the other important things that I learned when starting was to really focus on what you need to do. So when you are doing science, of course, you have a goal to publish something or whatever, where you can go around and do and dig into different areas and not waste time, but spend your time researching and reading and doing all those things. When you go into do work for a business, that you have a goal and you have to fulfill that. You have to complete those goals. You have to reach a target. So you have to focus on what you need to do and work in a methodology. So that's something I didn't know anything about how to work in a Scrum methodology, what's Agile, and all those things were super new to me. So I had to adapt to be part of a team that had a backlog, and you have a specific task for that week, and you have to communicate every day on what you were doing. So it was a very different experience, because what I learned was to do machine learning. That's what I learned. I didn't learn how to do data science. I learned that by working, of course, I took some courses and so on. But what I knew was how to do machine learning, not how to embed machine learning to a project for real.
Yeah. Well, that's a great point. And I think a lot of people, especially if they're transitioning from something else into data science organizations, working at organizations, that's one of the challenges. Communication, I hear a lot. Decision-making and timelines. Yeah. I wonder, when you're making decisions about whether it's as simple as, one way of framing a coding example as opposed to another, or maybe a huge thing like how will we map out the next 6 months or something, has your decision-making changed with that experience you were talking about? And if so, what's different than before and after?
Yeah, good question. So when you start, the biggest problem you have is that you don't have the experience of doing things, and you don't know how long it's going to take. Because in most cases, I think this is the reality for most people, what we learn in courses and whatever you are, maybe even in college, the data is provided to you, everything is like happy, and you have a specific goal to do, and you know exactly what to do with the data sets. And so that's not the way things work in real life. Sometimes you don't even know where the data is. You have no idea who's the owner of that information. When you get the data, you don't even sometimes have a dictionary of what each variable means. Then you start having even more problems, because the goals for the business are maybe sometimes they are not that specific. So you need to start creating your own hypothesis, your own goals for the project. You have to separate complicated chunks of things into smaller chunks of tasks to fulfill and to do. And that's not something that you know how to do when you get started. The other thing that I learned by doing was these Agile methodologies. So when I started in agility, I started in a Scrum scheme, and I really didn't know what was my idea of what I was supposed to be doing, right? So I started off by just doing my regular job, and then suddenly I had someone asking me, how was my day? How was the thing I was supposed to do? What are my blockers for tomorrow? And it was like, what's going on, right? So originally, I got very into agility, and I created a methodology for data science that takes into account agility. And I presented that. I wrote a paper on how to include agility into data science. I presented that, I think it was 3 years ago. And suddenly a lot of more people were thinking about agility and data science. And in the past 6, 7 months, I've been very into one thing that I recommend for everyone to read. It's called Data-Driven Scrum. It's a new way of doing Scrum that takes into account the uncertainties of doing machine learning. The bad thing about Scrum is that sometimes it's very rigid, even though it makes like it's a contradiction because it's supposed to be so agile. Sometimes having 1 week, 2 week sprints to do this and so on, it's not that clear when you're experimenting. And machine learning is experimentation. You don't know what's going to happen tomorrow. You have no idea what's going to happen for real. So you have to be aware of those things. And this data-driven Scrum has been very interesting for me. And I have applied that in the past months with great results because you take out pressure from the team. Now they don't have to really understand everything that's going on at the same time, but they have a plan and they can act upon that plan and they don't feel the pressure of sprints and so on and so forth. So again, we can dig into that later, but it's a very interesting thing that I'm doing right now.
Yeah, one of the questions I had for you, like to follow up on that, was one of the terms I learned was MVP, minimum viable product, as something to focus on or get done, which as an academic is very hard because you want your publication to be perfect, right? You want your example or whatever you're presenting to be perfect. Whereas the business goals usually prevent you from making a perfect product. There may not even be a perfect product. And so I wonder, how do you weigh those kinds of things where I'm sure, like most people, you want this, whatever you're working on, to be absolutely perfect. But the realities usually constrain you because of time, budget, and so on, that you have to knowingly not create something perfect. How do you deal with that, especially in data science?
Good question. And I think it comes up to culture. I think one of the things that needs to change in company in order to really do data science in an agile format is you need to change the culture, not only for the data science team, the whole company needs to change. This is what we call now a data-driven company and so and things like that. That's crucial because if you don't have that support, they won't understand what you're doing. They won't understand why you need more time. They won't understand why you need this budget or this time to do these things. So that has to be clear. And doing MVP is part of this agility. And it's something you have to learn how to do because the way we learn a lot of things is to present a perfect product, as you said. But that has a lot of problems. Sometimes you will spend some time in a feature that was not needed. Sometimes we'll spend time doing things that were not actually the idea for the business. So having this extra communication and extra steps and build stuff step by step and presenting the results, going back with the feedback and doing over and over again has the advantage that you are sure that what you're building is going to be used and what you're building is going to add value and is going to answer the questions for the business. So doing MVP is something I always do when I work in any project. If it's small, if it's big, this is the first step. We have to define the time period to have this MVP. What are the tasks needed to complete that? And that in the beginning is a complicated part of doing data science if you do it like this, because the business was used to get the whole product. But then they forgot that when we delivered the product, they were coming back, oh, I didn't like this. You can change this now. So sometimes they forget that that happens. So when you explain and you change the culture of the company to be agile, this is where it gets interesting when people understand, oh, this is the first step of the product. I'm not going to ask crazy questions because I know this is just a demo. This is just something that's to get started. But that needs to happen. It takes time. It may take some years for the company to really do that. But when it's done, I have only seen good things about it. So it's hardly the case. Maybe in 10 years, it will be a different story. But so far, I haven't seen anyone going into this MVP agility space and go back to say, oh, no, we were wrong. We have to go back to waterfall and do everything step by step with a Gantt and people doing things. So I have never seen that before.
Yeah, that's a good point. And then I guess when let's start with a little bit about what you're doing, because obviously it seems like everyone this year, or in the last couple of years, has been talking about artificial intelligence and AI and machine learning. So let's start with maybe you saying a little bit more about how you are using or working with AI and ML. Like, what does that mean to you?
Of course. So I work in a company called H2O. H2O is one of the leaders in the world for machine learning. We started off back like 10, 11 years ago with our first tool, is H2O3. It's fully open sourced, and we got the eyes of everyone. Everyone was checking what AutoML was. And that's a very important word I'll say later, auto machine learning. But right now the company has evolved a lot, and we are an end-to-end platform. And my job is divided into three pieces. First, I help the customers of H2O because we sell this platform. And when you sell the platform, so you want help from H2O to really do things, to how to use the platform. And I help people not only on how to use our tools, but I do the projects with them. So I manage the project, I do code, I work with them every day with several companies in the region, Mexico, Argentina, Colombia, and Chile, to do projects. I may go later to discuss these projects. So that's the first thing I do. I help the already customers of H2O. The other thing I do is the part for helping getting companies to view and buy the product. So I help in the pre-sales of H2O. That means I do demos for lots of companies. I do proof of concepts for lots of companies. And my job there is to present value and to say, this is what you do right now. This is how would you do it with H2O. So that's a lot of my time goes into demoing and doing proof of concepts and helping companies understand. That takes one more thing, and that is I speak in conferences. I go to the H2O booths in everywhere in the region. I have to travel a lot because I'm the head of data science for the region. So I go to all these conferences and meetings with people all around Latin America. And the third thing is to help with the products. So I'm not that involved in the creation of the product, but whenever I can, maybe I'll create an issue. I'll try to help with something. It's not part of my job description, but it's something I do because if I'm trying to use and sell this thing, I need to understand it very, very well. Mm-hmm. So those are the things I do. And just to be clear, what H2O provides for companies is three things. AutoML, that means you can automate machine learning. And you will be able to do lots of things that takes months or weeks, minutes, because we'll automate data cleaning, we automate feature engineering, we automate model selection. And we also have all these things about ML ops. It's a very hot topic as well. That is the development of models that will go into production and the monitoring, the versioning of those models. And just starting this year, we're also in the generative AI space with several tools to build your own LLM without any code. So we have something called LLM Studio, where you can upload your data sets and you can create an LLM. For someone that doesn't know what I'm talking about, it's something close to ChatGPT, but with your own data sets. Because if you ask ChatGPT, what will be the earnings for my next quarter, and you are a private company, you will have no idea. But you can feed those LLMs with your private information. And what we did in H2O was to create a system that enables companies to create their own GPTs or whatever without coding in a visual format. And we're moving into that space. And I think it's going to be very important for this year, next year. We're going to move a lot of the efforts to the generative AI space.
Yeah, I mean, super interesting. And also, of course, really hot topic right now. When you're talking to people and discussing this or doing demos, I'm curious, what are the most common misunderstandings or questions you get from potential clients or current clients when it comes to these kinds of things? What comes up the most?
I think the first question everyone asks is this going to replace data scientists? Because this is, so I mean, if you're automating machine learning, what's going to be the job of the data scientist? So that's the first question everyone's, okay, is it going to be a replacement? Is this going to be a new thing? So what I always do is I try to do an analogy. So if you are a designer, I can give you a piece of paper and a pen and to tell you to create whatever for me. You can create a logo, and you can create a branding and so on. And now I tell you, I need 4 different versions. I need 10 different colors. So if you only have a pen and paper, that's going to take a while, right? You're going to do the things over and over again, right? There's no trick to do it faster. You have to do it over and over. You have to paint, you have to draw, and so on. So now with the creation of Photoshop, Illustrator, and now all these generative AI things, the job of the designer is way easier. Of course, they need to learn how things work. They need to be able to replicate what they're doing, maybe by hand, but they want to work much, much faster. They can deliver proposals with hundreds of different colors in one day. It's not a problem of how slow can you draw. So this is the way I see auto machine learning. It's not that we are excluding the data scientists and this is magic and you have to click a button and everything will work. There's someone there that needs to understand what the system is doing. It's going to help the system create the solution, and it's going to be able to understand the result. If I say to someone that doesn't know anything about data science that the F1 of my model is 0.7, what's that for them, right? So you need a data scientist to understand those information. And the good thing I see about this part of auto machine learning is that it takes away the tedious part of data science. So it's not everything perfect. So you have to clean data, you have to prepare the information and go back and forth. You do a model, it doesn't work, you have to go back, to do the data changes again. And then, so that doesn't need to happen anymore with auto machine learning. And it's not something that it is super new anymore. So as I told you, we started in this path 10 years ago, of course, all open source. But now with the enterprise solution, so this is becoming a standard. And not even from H2O. There's a lot of companies. Google has one. Microsoft has AutoML. So every big player in the business will have, in the tech space, will have an AutoML solution because it's the way things are going to be happening. It's not up to, oh, no, I prefer to code and work 2 months on these things. Well, if the business can do this in days, it doesn't make sense to do it the other way. And the other question I get a lot is this even worse than a black box? Because people were scared of black boxes when we were in charge. Now imagine they have another, between quotes, black box that does for them everything. So the good thing about what we do in H2O is that we explain everything for the user. We create documentation automatically from every model. We have explainability. We have a lot of different solutions to explain the model, the data, the transformations, the parameters. So everything is in place for you to understand. So I think a lot of people are scared to go into these more advanced techniques for machine learning because they don't really know what it is. They feel it's going to take their jobs away. They feel that they won't understand what's going on. But it's just the opposite. And we have seen that over and over again in our customers. People were doing good, but now they're amazing because they are faster, they're more efficient, they can create more projects in the same time period, they can save money. So all good things.
Yeah. And I mean, as you said, it seems to be where everybody is going. And so it's just almost the table stakes now, or it will be very soon for most companies. What are some of the ethical or other just general questions or concerns that you would tell people about, that you would warn people about? So I can imagine the opposite of what you described in some sense, where people are all eager to jump in, they start getting going. What do you need to warn them about or make them think about if they're eager to just embrace this?
Good. One thing that is in our tool and also in other tools is a check for bias and fairness. So the data can be biased, but also the model can be biased, even if the data is not biased. So those things you have to check. Even if you are doing AutoML or you're doing classical machine learning or deep learning, whatever you're doing, a ChatGPT, you have to check for bias. Because that can, I mean, if your company is big, and for us as customers, we have all the big banks in the United States. So we are changing the world and we're changing reality if we have biased models. So we have to be very responsible and accountable for what we do. And those checks are needed. They're not optional. So you have to check if the data is not systematically biased if there's no errors or corruptions in the information. You have to check if the models are fair to predict for everyone. And I'm not even talking about people, sometimes even machines. So you can have a bias model for machines. In here, it's more tricky because it's not about the ethical part for machines, but it's about problems for the system. If the model always predicts one thing, it's getting one machine right, but the second one is not getting it right, you need to check for that. And it's more complicated than just the people bias and being unfair to people and stuff. So you can also be unfair to the products and machines involved in a project that is being predicted by machine learning. So my recommendation in here is to read about ethical hacking, is to read about ethical AI, understand what are the different steps you need to check, because this has been talking about for years now, and we have like check boxes. Oh, did you check this? Did you check that? So there's a lot of books and material to understand what are the checklists that you need to do, and make sure that whatever platform you're using could be open source, could be enterprise, could be cheap or expensive. Make sure that the company doing that is aware of these things and is providing you the tools to check by yourself if your model are not biased, if they are solving problems in an ethical way. And one extra dimension is regulation. So sometimes, and I'm not going to speak for the United States, but I'm going to speak for Latin America, AI is not that regulated. So we have a lot of space to do whatever we want. And sometimes that's good, sometimes it's not good. I think it's going to change. I think in one point, governments are going to start regulating what we do everywhere in the world. That has started in the US, that has started in Europe. It's going to come here, I have no doubts. But check for regulations, because some companies, even though if the country is not regulated, maybe your company has regulations. Maybe you cannot deny a credit by gender. Maybe you cannot deny credit by age. Maybe you cannot check people information from the database that you're seeing. So you have to be aware of all those things that sometimes are not clear. When I started, I had no idea about data privacy, data security, and all of those kind of things. No one tells you. And sometimes they'll give you a data set, you create a model, and then there comes someone from regulation and say, this cannot go into production like this. You have these data, these variables are forbidden. So those things you have to check prior, because you can waste months doing a project that will never go into production because it's not ethical for the company to do.
Do you partner with data professionals and want to apply insights towards strategy? Pragmatic Institute's Data Science for Business Leaders course will help you uncover business value, make informed decisions, and drive impact with data. Become a data-driven leader at pragmaticinstitute.com/data. Yeah, I'm wondering if you could say a little bit more about that. Like, there's definitely the sort of quote unquote well-known biases, right? Gender, sexuality, race, and these things that are protected definitely in the US by law. And you cannot choose things or you cannot gear things so that they benefit one class of that nature or another. And so we can kind of tell, and there's been horror stories of stuff like hiring where they go for certain kinds of gender or certain kinds of races, and they establish that later, and then they obviously face a backlash and will change and face legal suits. But what about inherently bias is something that is unconscious or unseen. So how do you know to check for that, especially when it's not maybe so obvious as you're giving men preferential treatment to women? You can kind of see that in the results if that's what you're looking for. What are some of the more subtle ways that you look for and check for bias?
So one of the things you have to do is to divide data into cohorts. Sometimes not by gender, not just start randomly. That's the first thing I do. Just divide the information randomly and start predicting for those chunks. If everything looks fine, maybe you are in a good path. But maybe you'll see that for this part of the information, you don't have good predictions. So of course, I'm going to talk about two things. First is the performance of the model. That can also be an indication of bias. But the other part is going to be more philosophical. But let me start with the first part. So if you're checking for performance, maybe, so start dividing the data into cohorts, check for performance of the models in each part of the data set. If it looks similar, you are in a good path. Then go into more detail, divide the information into different groups per several variables, and try to do that over and over again until you see that the model is fair for each portion of the information. So that's the technical part of checking things. All right. For example, in there, because I didn't say anything about putting age or gender in there, just put everything. Maybe you'll realize, oh, I didn't realize that this chunk of information is only about women. Oh, there's a problem there. I checked that this information is only about machine number 4. So you start seeing things that you were not looking for. That's the hardest part of being ethical doing data science, because the obvious part are meant to be and they're there and you have to do it. But what about the not obvious part? So you have to start digging in to see those kind of things. And the other more like ethical part of this, more human, is you need, so whenever I do a project, I always think about that these data points are not data, it's people, right? So you're messing with people's life. I mean, I have worked for banks, for insurance companies, and I don't want to have the burden in my head that I denied someone an insurance when they were supposed to get it, right? So that part is important, because when you stop seeing numbers and you start seeing people in your data sheets, everything changes. You don't see that anymore as I had to do this by Friday, but you are start getting inspired by thinking that you're changing the world. And we are. Most of the data science work we're doing is going to change reality. So that more philosophical part, it's important because it will turn on some lights. Oh, did I check for this? Did I check for this type of bias? Did I check if this variable was normalized? Did I check this if this information from the origin was like really thought about how to get that information? And you have to check for different types of errors, human errors. For sometimes when you said something that's very interesting, you cannot in the United States like have a model that is gonna prevent someone from one race to be hired. Sometimes the people don't know. Sometimes the people don't know that. Sometimes people that created the model are neglecting one race without even knowing about it, because they were seeing numbers in the screen and not people in the screen. So that's what so you have to check for systematic bias, for the data, for how the data was created. Was there any problem in the data creation? You have to check with the data team. Is there anything I have to take into account? Is this variable well created? Second, you have to go and check cohorts, validate different type of information, run the model several times, do a lot of experimentation, maybe A/B testing and whatever, and then start thinking on what you're doing and be inspired, because you are changing reality and you have to be aware of what you're doing, and that will change the way you work.
Yeah, I'd love to know more about that reality changing potential. When you're approaching people or when you're dealing with clients, what are some of the more sort of low-hanging fruit, like the more obvious ways in which you can use AutoML and some of these other related technologies? And what are some of the ways that haven't quite been used yet, or that are maybe a little harder, but you predict that they'll be doing that soon? What are some of the more basics, and then what are some of the more distant goals?
So whenever I start with a company that I manage here in Latin America, I always go to the, as you say, low-hanging fruits. What are the things that are going to be done faster that will make more return for the company? So you have to do an inception. This is what I call it. So you have to go to the business team with the data science team and think about what are the biggest problems we have and how can we solve it. In most cases, they know. In most cases, when they come to you, they know what they need to do. But sometimes it's not that easy to understand what are the problems. So what I always do is to get started with those big things that will make more return, because if they see an ROI for the tool, of course, it's going to be a no-brainer to buy H2O. So I think in those terms. If I do a POC that improves 20% their performance right now, how much money are they going to make? If they're going to make $1 million more, it's not going to be hard to sell H2O, right? So those kind of things I always think about. Then what I have seen in these companies is that everyone wants a piece of the cake. Everyone gets to talk about, oh, did you see that finance did this model and now they're having these earnings this year, and they're getting recognized, and people got promoted and whatever and so on. So people start to getting, okay, I want a piece of that. I want machine learning for my team. And so there are companies that started with us with the basic stuff, the more crucial like revenue and promotions and understanding forecasting and demand. And now they're doing everything. They're understanding HR, they are understanding finance, marketing, everything in the company is starting to be alive. And in most cases, people get started by doing table machine learning. It's what I call table machine learning, is using data in a table format. That in most cases is what you do. You have an Excel sheet, you have a SQL database, you have a database with information that is structured into columns, and you do machine learning. Most cases, that's what we start. It's called traditional machine learning. Mm-hmm. But when that is done, people get creative. And that's the interesting part, because particularly for my case in H2O, we do have a lot of tools for deep learning and natural language processing and audio machine learning and video machine learning. So those kind of things people never even thought about before. So it's much more advanced. You need to have quantity of data that sometimes you don't have. And people are even willing to start collecting information with the promise of having something cooler in the end that will make them more money. So sometimes companies that I have managed say, okay, we don't have this, but I'm going to have this in 4 months. So we're going to work on the other things, and the data will be here in 4 months, and we can get started with these kind of things. So that's what I see. We start with the biggest impacts we can have, these quick wins that will make the company successful, that will make the data science team more important in the company. When they have that backup, when they have that trust, they can get more creative. Some people go backwards, and that is not something that works. Some people want to do incredibly weird stuff that is, I don't know, they saw maybe in a video in YouTube for their company without even checking the boxes. Hey, but you don't have this. You don't have a churn model. You don't have a demand planning model. What are you going to be doing extracting in the audio for customer calls and the sentiment? So you don't need to go there if you don't have the boxes, because in most cases, those things are going to make much more money than the weird and wild stuff you're imagining.
Yeah, it's an interesting balancing act. I wonder if there are ways in which you've seen people thinking about where to bring in machine learning versus where they may want people, like actual physical people. Like I'm thinking for the example you used, right? If you're extracting audio and doing a sentiment analysis to find out whether a customer, let's say just on a basic level, is happy or sad, I'm sure the caller, the person who works there, could say, I know whether they're happy or sad. I just spoke to them. I could just click a box and say that. So I wonder if there are cases that you've seen that are either really good or really bad for where to start implementing.
So I think the bar is in scalability. Sometimes it's not that easy. So most of the things machine learning models can do, we can have a person there. We can have a person when someone is buying something to see if it's that person, but that's impossible to do. If you're a bank, you cannot have 20 million people following your customers around just to see if they are who they are. So scalability is something crucial. So when you want to scale something and automate something, machine learning works amazing. But sometimes people go over the top. And this is again more future thoughts, but I think we're going into a world where the space for being human is going to be less and less important. Let me be clear in here. The way companies are building stuff right now, and the way we are thinking about the future of AI is neglecting a lot of humanity. So I don't agree fully with that. I think it's inevitable. I think we are going to that direction because what companies want to do, make more money and spend less money. And if that means firing everyone, they'll do it. And we have seen that a lot. The past year and this year, we have seen massive people getting fired. It's not random. They know what they're doing. They know that a lot of these positions are going to be replaced by AI in a period of 1-2 years. So they're preparing for that. It's not because they don't have money. I mean, Microsoft is making billions and they cannot have these people paying him $2,000 per month. I don't see it happening, right? So I feel that we're going to go into that direction where you want to see a person, but you will see a machine. I don't feel that happy about it, but I think it's going to be happening. And you're going to be seeing that for chatbots, less people in customer calls. And we're going to talk about not only that these people, what we are replacing a lot of positions that are important. I don't see it crazy that in 10 years, a CEO can be a bot. Right now, it feels insane, right? But 5 months ago, it was insane to have a system that generates code for you. And you can do that right now, right? So yeah. I'm not scared, but I'm preoccupied that some of the things we're doing in AI are taking away the power of us for being humans. And I would like to see more people working in the way of co-pilots, helping. We are going to be there with you. We're going to help you. This system is going to make you live better. You can spend more time with your kids. That's what I want to hear. But that's not what I'm seeing. And being inside of the company, because I am inside of this. I'm not an outsider. I'm not a user. I am one of the creators of this problem, maybe. So that's why I have the responsibility to talk about these things, because sometimes it gets really scary to see which direction we're going. So yeah, that's it.
Well, and for people listening who hear that and are perhaps worried, especially if they're like early in their careers and they fear that they may be one of those first people let go because of improvements in AI, what kinds of advice or tips would you have for them to maybe either stay relevant or plan where they're going to be or what kind of skills they're going to acquire? What tips do you have for people who are worried about what you're just describing?
Good. I have 2 recommendations for being relevant. One, it's been incredibly amazing technically, that you are the best of the best and no one, even a machine, can replace you. That path seems complicated, right? But there are people like that. I mean, if you go to the biggest companies in the world, they will tell you if you fire this guy, the company will fall. So you can be that guy or whatever. So you can be that person that is you have all this knowledge, you have trained a lot and you know all these things and you are adding so much value that it's impossible to let you go. But the other path, I think, is going to be easier for some people and complicated for others. And the other path I see is to be more public. What do I mean by this? If you are great, but no one knows that, it's kind of hard that you're going to be there forever in that company. So how to be public has a lot of different things, but you can be public inside of a company. So make sure to speak, make sure to communicate. People know what you're doing, your work, that you're adding value. I mean, if you're not doing that, don't even think about being public. Of course, the first step of being public is to do things, right? If you're just sitting there and being mad about going to work, bye-bye. You're going to get away. But if you're really working and you want to be there in the company and you see that you have potential to add value, be public about it. The other part of being public is to be really public and to go to conferences, talk about it, create your LinkedIn profile, create blogs, create YouTube videos, explain to people, teach. So if you do that, and I have done that for the past years, that has changed my life forever. I had a podcast as well. I did webinars. I speak in conferences. I'm a teacher. I have taught data science to thousands of people. Now I'm more relevant. Of course, I have all these things I've done technically, and I know my stuff and I studied whatever. But this public life has really changed my life. And now I get invited into podcasts. Now I talk to people. Now I am someone that for the company I'm working with, they see me as a strategic value. So they see a strategy in me. Oh, Fabio is here. He can go to conferences. He can speak. He can talk to customers. He can be that person that speaks about what we do. So that's not easy for everyone. Not everyone in computer science has these skills. Some people went into computer science to not speak to anyone. I know these people.
Yeah, yeah.
So it's not going to be that path for you, maybe. So you really have to be relevant by being too technical, by really going deep into things, focus on doing projects, adding value. So if you can combine both, you're a winner and you can go up in the ladder of the companies.
Yeah. I mean, good advice. And I think, as you said, things are changing so quickly that it's funny to think that a while ago, people didn't really know those terms, data science and machine learning and artificial intelligence, or weren't using them commonly. Now they're so common that it seems everyone has an opinion and wants to share advice on it. What do you imagine is going to be happening in the future, or where do you have your sights set or your attention focused on maybe positions like a data scientist or a machine learning engineer that we wouldn't know existed a decade ago? Now they seem to be everywhere. What might be the next thing or some of the next areas that you're thinking about?
So there are three careers, positions that I see that will be more important in the next years. One is becoming famous. It's called prompt engineer. I see it like a weird position, but it's real. And
Yeah.
people are paying for that a lot of money. And prompt engineers are people who really know how to talk to these large language models. It seems that it's super easy, but if you really want to take out the value, you need to understand how to build these statements. And there's a whole science into it. And there's people that really understand how to create these prompts and able to get the best results, not only for large language models, for visual models as well. These things like Midjourney and DALL-E, if you search online for prompts and compared to what you were doing, they really know what they were doing. So this is something that's going to be happening because a lot of companies are going to be investing into large language models, into visual generative AI, and they'll need people to talk to these things. So that's going to happen. The other one that is not that new, but it hasn't been widely accepted yet, is called decision scientist. This is something that exists in Google. One of my friends, Cassie, she's the chief decision scientist in Google. And Cassie, so I asked to her, so what's the difference, right, between a data scientist and a decision scientist? And she said that is about the power to transform the company. When you are selling, I mean, if you say to someone you are a decision scientist, they think about you making decisions, not only about creating plots or doing models, but really going into production and be there and be an active part of the development of the product. And that is something that's going to happen because everything we do right now, this machine learning, is going to get automated. There's no question for that. Data cleaning, SQL code, Python, that's going to be automated. In some years, no one's going to be coding in Python anymore. So what's going to be the idea for these people? They know all these things. They know machine learning. So now they can add value in a different way. They add value by helping companies to create this model into production, to explain things, to communicate results, to help make decisions informed. So all those things in critical thinking is going to be more important in the next years because everything's going to be so automated. What's going to be left for you is to critically think about the results of the models. You have to be very good at that. The last one is a term coined by a friend of mine called Matt Dancho. He has a company called Business Science. And that is what is his proposal, that people need business scientists, not data scientists or anything, business scientists. And what is the difference he sees from data scientists? That these people really understand the problems in the business. So he has courses and stuff like that. And one of the things he does is to transform people from an analyst or a BI or someone in the business to go into data science. So they will have all this baggage, all this information they have learned from years of being in the company, of suffering the problems and pains. And now they know machine learning and now they know AI. So they can take all of that information and do business science. So I think those things are not that talked about right now. The most important one at the moment is prompt engineering, but I see decision science or business science. Maybe the name is not going to be like that. I mean, data scientist is just a term, But
Yeah,
the
yeah.
things we do is very similar to what a data miner we're doing. So it's going to be rebranded. There's things are going to change, but in most cases, it's kind of the same thing.
Yeah. I mean, and that already gives us so much to think about, people listening to this. Much of it is very exciting. Some of it is anxiety producing. I'm sure there's all these variations as well. But for people listening, if they're thinking about all these things you've been talking about, but don't know where to start, what are 2 things that they might be able to do today or tomorrow that would at least start to make some kind of improvement, whether that's strategic for their career or just for the business issues that they're dealing with? What are a couple things that they could do right now that would have an effect?
Great. So that answer depends on the people. If the person that wants to join has some technical background, I have an answer. And if you have no idea of anything, I have a different answer. So let's go if you have a technical background. I will divide this into 2. So it's 2 recommendations. First, open a LinkedIn account. It seems like what I'm talking about doesn't make sense, but LinkedIn is not only about finding a job. It's a community that's vibrant in there. It's one of the best communities for data science in the world. I will say Twitter, but it's sometimes toxic, so don't go to Twitter sometimes. But LinkedIn, it's people act professionals, most people. And there are groups, there's people. I mean, I create a lot of posts in LinkedIn every week explaining a concept. I upload videos, and people like me. So we have thousands of people helping others, learning more, because sometimes you don't know where to start. So LinkedIn is a great place. Find some people that you have to follow. Follow some, between quotes, influencers, and you will be in a right path, because they will point out courses, they will point out books, they will tell you read this blog. So you have a way to get started. And the second recommendation for people who has some technical background is to start working on mini projects. It's going to be even more important than doing a different course or going into a boot camp. Doing mini projects by yourself or with a group of friends is going to help you a lot, because you're going to see your reality. You have to download the data, create your own data sets, build your models. And if you have the chance, you can go public, as I said, and publish those things. You can do a blog, or you can do a Kaggle notebook on those information, and you can get recognized even if you don't have experience. Most people will ask for experience when starting a job. If you don't have that, but you have a portfolio of projects, you have something to show. Oh, I have done these 10 projects. They have been recognized. I have blogs. People have read it. So that's something to get started. If you have nothing, getting data science is going to be hard, because people are going to hire experienced people. It's the same thing for everything. Okay, so if you have no technical background and you want to get started and you have no idea where to start, so 2 recommendations. First, check some podcasts like this that are super interesting, because you get a lot of information really fast.
Yeah.
And of course, there are a lot of podcasts. There can be thousands of data science podcasts, but search online for the best ones. You'll find them, right? And listen to some episodes. Try to find the episodes that are about intro to machine learning, getting started, and hear those kind of things. And companion that with blogs. There's one great Medium page called Towards Data Science, where you can find a lot of different blogs. Me particularly, I have written more than 100 blogs on that particular page, and you'll find blogs that I wrote several years ago on what was my path, how I started, and how I recommend people to get started with information and books and so on. And you'll find not only for me, for thousands of people helping each other. So that's the first part, reading blogs, finding podcasts that you can hear and understand more. And the second part of the recommendation is finding a mentor. Finding a mentor is important. If you cannot find a mentor, at least ask a friend or ask someone. So countless people write to me on LinkedIn every month asking, how can I get started? I don't have the time to be mentoring them, to be there with them in the learning process, but I can say few things on how to get started. I can tell you which books you need to read, which courses you need to take. If you're very young, which career may be better for you, if you want to get into data science. And again, it's not only about me. It's a lot of people that are willing to help you and they're not going to charge you a dime for that. So you don't have to pay for it. Of course, some people will not be that easy or accessible, but most people I know are very flexible and willing to help people. I am where I am right now because of a lot of people. I learned from a lot of people, and I started blind. Hey, what's data science? I had no idea. So I asked people on LinkedIn, on Stack Overflow, on things, friends of mine, teachers. So those things are going to be helping you a lot. Getting started. By zero, you need mentors, you need friends, and you need to be able to focus. So that's going to be my recommendation.
Awesome. Yeah, I was going to ask where people should look for you and your work. So I would assume you'd point them to LinkedIn. Where else? And Medium?
Yeah, so you can find me on Medium as Favio Vazquez. So I have more than 125 blogs in there. You can find me on LinkedIn. Same thing, Favio Vazquez. I cannot accept more people due to LinkedIn because I reach the top connections on LinkedIn. But you can follow me if you want to check more about what I do. And lastly, I'll say not my YouTube because I haven't posted in years, but the H2O AI YouTube channel. Sometimes you'll find videos of me explaining topics, not only about H2O. So I'm also focused on explaining people what machine learning is. So I just uploaded 6 to 7 videos on what is machine learning in Spanish in the YouTube channel for H2O. So if you want to find more videos, you can also type my name on YouTube. You'll find my webinars, you'll find my conferences if you want to know more about what I do.
Awesome. Well, Favio, we've taken up a lot of your time and you already started the ball rolling, I think, for a lot of listeners who maybe didn't know where to start. Now they have some really clear and pragmatic ideas about how to do that. Yeah, I mean, it will be very interesting to see what you're doing in the next few years and for people who are following you and for everybody working in this space. So yeah, I just want to thank you for your time and for your insights.
Thank you, Chris, and thank you for inviting me here. Happy to be part of this great job you're doing, explaining people what we do. So thank you for the opportunity. Thank you for everyone listening. I'm happy to hear from you. So just send me a message and we can talk. Thank you, everyone.